Hello there, curious minds. Today we're ditching the textbooks and stepping into my rather unusual laboratory. My kitchen, yes, you heard that right. We're about to unlock the fascinating world of biological molecules, those tiny but mighty building blocks of life itself. And what better place to do it than surrounded by the sights and smells of culinary creativity? Think of it this way. Every time you bake a cake, toss a salad or sizzle up some stir-fry, you're engaging in a delicious dance with carbohydrates, lipids, proteins, and nucleic acids. These are the stars of our show today, the fundamental components that make up every living thing on this planet, from the smallest microbe to the tallest giraffe, and yes, even you and me. So put on your chef's hat, grab your metaphorical microscope, and get ready for a whirlwind tour of the molecular marvels that fuel our bodies and make life possible. We'll be exploring the sweet world of sugars, the slippery slope of fats, the protein powerhouses that keep us going, and the nucleic acids that hold the secrets of life itself. Get ready for a wild ride through the fascinating world of biology, all from the comfort of your own kitchen. Before we dive into the nitty-gritty of carbohydrates and their kin, let's take a little detour to the early 19th century and meet a rather intriguing character named William Prout. Now, Prout was a physician with a rather unusual fascination. Urine. Yes, you read that right. Urine. See, back then, people believed that your pee held all sorts of clues about your health and personality. Think of it as the 19th century version of those personality quizzes we all love to take online. Prout, however, was more interested in the chemistry of it all. He spent years analysing urine and made some groundbreaking discoveries. For one, he figured out that our stomachs contain hydrochloric acid, a highly corrosive substance that could eat through metal. I wouldn't recommend trying that at home, by the way. He even wrote a whole book about kidney stones, those pesky little crystals that can make life rather uncomfortable. Now, you might be wondering what all this has to do with biological molecules. Well, Prout's work, as peculiar as it might seem, laid the foundation for our understanding of digestion and metabolism, the processes by which our bodies break down food and extract energy from those very molecules we're about to explore. So, the next time you enjoy a hearty meal, spare a thought for William Prout, the urine enthusiast who helped us understand how our bodies turn food into fuel, Let's kick things off with carbohydrates, those energy-packed molecules that often get a bad rap in our diet-obsessed world. But don't let their reputation fool you. Carbohydrates are the primary fuel source for our bodies, providing us with the energy we need to power through our day, from our morning jog to our late-night study sessions. Think of carbohydrates as the body's go-to energy bars. They're like readily available snacks that our cells can easily break down to release energy. But just like energy bars come in different shapes, sizes, and flavors, carbohydrates also come in various forms, each with its own unique set of properties. We've got the simple sugars like glucose, the rock stars of cellular energy, and fructose, the sweet stuff found in fruits. Then there are the double-duty disaccharides like sucrose, the table sugar we know and love, which is just glucose and fructose holding hands. And finally, we have the complex carbohydrates, the long chains of sugar molecules like starch and cellulose, which provide a slow and steady release of energy. From the sweet taste of a ripe mango to the starchy comfort of a baked potato, carbohydrates are an essential part of our diet and play a vital role in keeping our bodies running like well-oiled machines. Section 4. Simple sugars, the building blocks. Let's start with the simplest of them all. Monosaccharides, the building blocks of the carbohydrate world. These are the single-molecule sugars that provide quick bursts of energy to our cells. Think of them as the tiny batteries that power our every move. The most famous of these is glucose, the superstar of cellular fuel. It's the primary energy source for our brains and muscles, and our bodies go to great lengths to maintain a steady supply of this vital sugar. From the moment we wake up to the time we hit the pillow, our cells are constantly buzzing with activity, powered by a steady stream of glucose. Then we have fructose, the sweeter cousin of glucose. Found naturally in fruits, honey, and agave nectar, fructose is known for its intense sweetness. It's the reason that ripe mango tastes so delicious and why honey drips so seductively from a spoon. While both glucose and fructose provide energy, they take slightly different paths once they enter our bodies. Glucose is like the eager beaver, quickly absorbed into the bloodstream and readily available for use by our cells. Fructose, on the other hand, takes a more leisurely route, getting processed by the liver before it can join the energy party. So the next time you bite into a juicy piece of fruit or indulge in a spoonful of honey, remember that you're experiencing the sweet power of monosaccharides, the building blocks of the carbohydrate world. Section 5, complex carbohydrates from potatoes to paper. Now let's move on to the big leagues of the carbohydrate world, polysaccharides, the long chains of sugar molecules that pack a serious energy punch. These complex carbohydrates are like the family-sized bags of chips of the carbohydrate world. They provide a sustained release of energy that keeps us going for hours. Think of starch, the energy reservoir found in plants. From the humble potato to the mighty grain, starch is how plants store their hard-earned energy from the sun. When we eat starchy foods, our bodies break down those long chains of glucose molecules, releasing a steady stream of energy to fuel our activities. Then there's glycogen, the animal kingdom's answer to starch. This branched polysaccharide is our body's way of storing excess glucose for later use, like a savings account for energy. When we need a quick pick-me-up, our bodies tap into these glycogen stores, releasing glucose into the bloodstream to power our muscles and brain. But not all polysaccharides are digestible. Take cellulose, for example. This tough and fibrous carbohydrate forms the structural framework of plant cell walls, giving them their rigidity and strength. It's the reason trees stand tall and celery stalks snap crisply. While we humans can't digest cellulose, it plays a vital role in our diet as fiber, keeping our digestive systems happy and healthy. So the next time you enjoy a bowl of oatmeal or a crunchy salad, remember that you're experiencing the power of polysaccharides, the complex carbohydrates that fuel our bodies and build the world around us. Section 6. Lipids, fats, oils, and cellular barriers. Let's move on to the next contenders in our molecular marathon. Lipids, the fats, oils, and waxes that often get a bad rap in our health-conscious world. But just like carbohydrates, lipids play a vital role in our bodies, providing energy, insulation, and even forming the very membranes that enclose our cells. Think of lipids as the body's long-term energy storage units. When we consume more calories than we burn, our bodies cleverly convert the excess energy into triglycerides, the most common type of fat found in our bodies and food. These triglycerides are then stored in adipose tissue, those soft and squishy areas better known as fat deposits. But lipids are much more than just energy reserves. They also play a crucial role in cell signaling, insulation, and protection. Phospholipids, with their unique hydrophilic or water-loving heads and hydrophobic or water-fearing tails, form the very foundation of our cell membranes, acting as gatekeepers that control what enters and exits our cells. Then we have steroids, a diverse group of lipids that includes cholesterol, hormones like estrogen and testosterone, and even vitamin D. These powerful molecules play essential roles in cell signaling, hormone production, and even immune function. So, while it's wise to be mindful of our fat intake, it's important to remember that not all fats are created equal. Lipids are essential for life, playing vital roles in energy storage, cell function, and overall health. Section 7. Proteins, the body's workhorses. Now, let's meet the real workhorses of our cells. Proteins, the complex and versatile molecules that perform a dazzling array of functions in our bodies. From building and repairing tissues to transporting oxygen and fighting off infections, proteins are involved in virtually every aspect of life. Think of proteins as the body's construction workers, enzymes, transporters, and even soldiers. They're the ones who build and repair our muscles, catalyze metabolic reactions, transport oxygen throughout our bodies, and fight off invading pathogens. The building blocks of proteins are amino acids, small organic molecules that link together like beads on a string. There are 20 different amino acids, each with its unique properties and side chains. The specific sequence of amino acids determines a protein's unique three-dimensional structure and function. Proteins fold into intricate shapes like origami masterpieces determined by the interactions between their constituent amino acids. This precise folding is crucial for a protein's function. Just like a key only fits into a specific lock, a protein's shape determines its activity. From the keratin in our hair and nails to the insulin that regulates our blood sugar levels, proteins are the unsung heroes of our bodies, quietly carrying out their essential tasks to keep us alive and functioning.